Mercury is the only metal that's liquid at room temperature, and it's able to easily form alloys with most other metals. In chemistry, it's pretty common to combine sodium and mercury, which can be fun and a bit dangerous. I did this a while ago on my main channel, and I basically just shoved sodium metal into mercury. The reaction generates a lot of heat, and it's usually enough to boil the mercury and light the sodium on fire. A little while ago, I made this little thing on my main channel, and it's called a YBCO superconductor. At room temperature, it doesn't do very much though, and I first need to cool it down using liquid nitrogen. Now that it's nice and cold, if I drop a magnet on it, it just floats. I can also poke at it a bit and get it to spin around, and it honestly kind of feels like magic. In the last video, I showed that if I put a magnet above a superconductor, it kind of just floats there like magic. What I want to do now, though, is show what happens if I do it the other way around. For this one, I'm using a much bigger superconductor, and I'm again cooling it with some liquid nitrogen. By now, it should be good, and I can take it out and drop it onto this little magnet track that I made. It actually stays on the track, and if I push it, it's able to move without falling off. It's also surprisingly strong, and even if I push it decently hard, I can't get it to touch the track. As it warms up though, it eventually loses its ability to superconduct, and it stops floating. Here I have some mercury, which is the only metal that's a liquid at room temperature. What's cool about it is that it can dissolve most other metals and form something called an amalgam. This is commonly done to purify gold and to separate it from raw ore. What I think is fun though, is to just throw some gold leaf onto it. As the mercury dissolves it, the gold is slowly pulled in, and it kind of looks like it's eating it. It's able to suck up a lot of them, and I can just keep adding more gold. This is nitric acid, and it's one of the few acids that can react with copper. But oddly enough, it doesn't work well when the acid's pure. This is because of something called passivation, where a layer of oxidized copper forms and it covers the surface and protects the rest of the copper. To get it going, I have to add some water, which will dissolve the protective layer and let the acid attack it. This more dilute acid can completely shred the copper, and all the metal should eventually disappear.